All right, hello everyone. My name is Robert Haas. I have worked at EDB for 15 years, incredibly enough. My current title there is VP Chief Architect Database Servers. And my talk this year is entitled Committer Review, an Exercise in Paranoia. And this talk came out of some remarks that I made extemporaneously at last year's PGConf.dev during the advanced patch feedback session that we had as part of that event. And several people told me that those remarks were helpful and that I should try to develop them into a talk so that everybody could have the benefit of the remarks instead of just the people who happen to be in the room at that particular moment. So that's what I've attempted to do here. I don't know whether you'll actually get a benefit out of them, but I hope you do. The agenda for this talk is pretty simple. I want to spend the first part of the talk talking about the committer mindset, or rather what I believe the committer's mindset to be. Obviously, not all committers have the same mind, and we have quite a few of them in the room, and I don't know what they all think. So I'll tell you what I believe people are generally thinking, and if I finish in time, maybe some of the committers we have here can tell me how or whether I might have gotten it wrong. And then I want to spend the second part of the talk talking about actually reviewing patches. So let's start with committer mindset. I think a lot of people have figured out that getting patches committed to PostgreSQL is pretty hard. And there are a lot of reasons for that, the overwhelming majority of which I cannot address in this talk. But I do think that this committer mindset plays a role, and I want to talk about that. I think people sometimes perceive that there is a certain reluctance on the part of committers to actually commit patches. And it may not be obvious to them in all cases where that psychological reluctance comes from. I think it basically comes from the fact that if you commit somebody's patch, you, not they, are responsible for whatever goes wrong. There are no excuses, and there is no statute of limitations. If you break the build farm, you must fix it immediately. It doesn't matter whether it is nighttime for you, a weekend, a planned holiday. It doesn't really matter whether there's a natural disaster occurring in the place where you are. The build farm is a shared resource, and you can't leave it broken. You need to fix it right now. But even if you get through that immediate post-commit window, either by fixing whatever goes wrong or by being lucky or skillful enough that nothing does, you're not out of the woods. Even many years later, you may be called upon to defend the design, to fix bugs, or to maintain the code. And one really good example of this, I think, is our support in PostgreSQL for just-in-time compilation. Andres mentioned to me at one point that at the time that he committed that patch, the LLVM interfaces upon which PostgreSQL was defending had been pretty stable for a while. Subsequent to that, they have not been so stable. Now, that's not really something that I can very easily do anything about because I am not familiar with those interfaces. In fact, probably most committers are not familiar with those interfaces. So what are we going to do when something needs to be updated to work with a new version of LLVM? Well, we're going to ask Andres, of course. I mean, he committed the thing in the first place. He must have at least some understanding of it. The good news here in this case, and this actually happens pretty commonly, is that sometimes other people will jump in to help. For example, in this case, Thomas Monroe has jumped in and has done a bunch of updating to keep PostgreSQL working with newer LLVM versions, which is really great. But you never know what is going to happen there. Andres has no way of knowing when he puts that patch into the tree how bad it's going to be. The LLVM project could change nothing, or they could change all kinds of things all at once 5 minutes after the patch is committed and every 5 minutes thereafter. There's just no way to be sure. And 6 other committers could show up and volunteer to help clean up the mess, or everybody could be like, your job. And you don't know. So whenever you commit a patch, you're accepting a certain amount of open-ended liability for the things that may go wrong in the future. And I'm guessing that there's probably nobody in this room who enjoys writing blank checks very much. And that's kind of what you're doing to a certain extent every single time that you commit a patch. So in that sense, it's a little bit of a miracle that we manage to commit a few thousand of them every year. One thing that I've also noticed is that you tend not to get much help at all from the patch author. And to be fair, sometimes that is because the patch author is on the opposite side of the planet, and so they're asleep when you're awake or whatever. And sometimes it's because they had no idea of the exact time that you were planning to commit the patch, and so they couldn't really be on standby to help you fix issues, even if they wanted to. And I have had cases where I have told someone in advance when I'm going to commit their patch, and could they please be available to help? And some people have agreed to do that. But even in the best case here, a lot of the discussion tends to end up getting left to the committer, and the author stays out of it. A lot of the writing of follow-up fixes tends to get left to the committer, and the author stays out of it. And so that naturally produces a certain amount of caution on the part of committers. So on the one hand, we have that committers are responsible for the issues that they create, and in particular for their mistakes. But then on the other hand, we have the fact that mistakes are actually quite easy to make. We have an incredible number of extremely talented people working on PostgreSQL, and all of them regularly introduce serious bugs. I also regularly introduce serious bugs when I commit things. If you look through the commit log, you'll find that data corruption bugs and server crashes make it into the source tree quite often. Sometimes these aren't caught before release, but even if they're caught relatively quickly, they still generate work. And of course, smaller errors are even more common. I probably could have made examples of commits from any committer, really, but I picked a couple of examples from my own experience here. In the lower left-hand corner of this slide is a fix that I committed for a bug that I had introduced. And this is the first data corrupting bug that I know myself to have introduced into PostgreSQL. It's possible there's an earlier data corrupting bug that I introduced into PostgreSQL, but this is the oldest one that I know about. And when Jeff Davis reported this issue, like, my heart just sank. Like, this was a bad bug, and it made it through to release, and it was in releases that we were shipping to people, I think, for over a year, and it was basically a one-line omission. There was one more function that needed to be updated for the work that I had been doing than the number of functions that I found. Jeff ended up adding a few asserts and comments and things, but the core of the fix was a one-line fix, and I missed it, and I don't know, and we'll never know, how many people suffered data loss as a result of that mistake on my part, but it probably isn't zero. And that sucks. The other example that I have here is much more recent. I recently committed a new contrib module called pg-overexplain, and the build farm broke, of course, despite the fact that the patch had 2 reviewers, one of whom was Tom Lane, and it took 3 commits to fix the build farm, which all had to be done that evening. And then by the following morning, a few people had read the commit, and they'd found more silly things that I had done that weren't breaking the build farm, but nevertheless needed to be corrected. And so what started out as an intention to do 1 commit turned out into 6 commits, and numbers 2, 3, 4, 5, and 6 are all public documentation of how foolish I was in commit number 1, which is always a great feeling. Now, don't get me wrong. Being a committer is a great privilege in many ways, perhaps most of all because of the amazing group of people that I get to work with, which is all of you. But I think it is very easy for a non-committer to imagine that when a committer sits down to type git push, they're feeling a bit like this gentleman right here, who seems extremely satisfied with his life and his privileges, and things are basically going as well as he could ever possibly like, and he's really enjoying what he gets to do. But in my experience, and the experience of committers I've spoken with about this issue, they do not feel like this guy. They feel more like this guy. The committers that I've spoken with feel that committing patches is stressful. I know that I find it somewhat stressful, and then I talked to a few other people, and they had described levels of stress that far exceeded what I was describing, and it seemed quite extreme. So, of course, as you can imagine, this leads to people engaging in painstaking and exhaustive verification of a patch set to the best of their ability before they push it, and then things still go wrong and they have to scramble. One interesting piece of evidence of how much of a problem this is that there are some great patches written by committers that sit on the mailing list for years without being committed. And you might find this really surprising. Hey, you wrote a patch, you have access to push it, you lucky person. Why don't you just do it? Well, they don't do it because they're afraid of what will go wrong. And sometimes another committer comes along a few years later and really needs to solve whatever the problem was, goes back, finds the patch written by the first committer and says, oh, this is great. The other person already did the work of figuring out how to solve the problem, and I was going to need to do that either way, but now I only have to be responsible for the aftermath of not also writing the patch. And so everybody kind of wins when that happens, except perhaps for the users who had to wait a couple of extra years for that fix. So far I've focused on, mostly on the extra work that commits can create. I did mention public embarrassment as a thing that I do think weighs rather heavily on the minds of a lot of people because, nobody likes that. And in extreme cases, people might even be afraid that they're actually going to lose their commit privileges. So that's all that I wanted to say about committer mindset. If we have time available at the end, I would love to get a few comments from other committers about that during the Q&A. But now I'm going to be talking a little bit about reviewing patches. What is the committer going to be checking? And therefore, if I'm the author of the patch or the reviewer of the patch, what should I be thinking about? There are a number of talks about this already, and there's so much that could be said here. We could go on all day about, literally all day, about things that you should check when you review a patch. Because there's a lot of them, and it's actually quite difficult to remember all of the things that you're supposed to check for every single patch. But the thing about it is, if I tried to do that, I think it would be less useful and maybe a little bit boring. So what I'd like to try to do instead is offer a few general principles. I'm going to spend the rest of the talk going through these one by one, but here they are briefly. So my first principle is start with the big picture. If the design of the patch is incorrect in some fundamental way, then it really doesn't matter whether the patch contains typos. I mean, it will matter at some point, but it doesn't matter yet. Second principle is that consistency is critical. It's okay to do new things in PostgreSQL patches, and in fact, we do that all the time. But the departures from existing practice need to be well justified. You have to have a reason why you're doing something different, and it should be more than your personal preference. The third principle is be a pessimist. Every conversation about every patch on the mailing list, or pretty close, always involves at least one person who thinks that the patch is good, because the author would not have submitted that patch unless they believed that it did something useful, that they'd done a reasonable job on it, and that it would benefit the project. Okay, I mean, maybe occasionally somebody phones it in, but for the most part, I don't think that's the case. But being a good reviewer requires questioning the assumption that the author got the patch right. And my final principle is to apply a spirit of maintainership. I think it is very easy when you're working on a patch and when you're having a discussion about the future of a patch to, make getting that patch committed, ideally on something close to its present form, ideally as soon as possible, your overriding goal that trumps everything else. But this is a project that goes on, and there are going to be, many more commits after your patch. And so we kind of have to think about the big picture and how your patch is going to accept the project overall, and not just about whether it is good in isolation. So I'm going to talk through this a little more, and let's begin with starting with the big picture. This is a sort of patch review hierarchy of needs. And the idea here is that all of these things are things that we care about. All of these things are things that have to be right. But the stuff that's down near the bottom of the pyramid is more fundamental, more foundational. The pyramid rests on its base. I think the absolutely most fundamental question for a patch set is understandability. Is the idea that the author is proposing clear enough that we can actually evaluate it in some meaningful way? And the second is similar, desirability. Is it actually a good idea? There is very little point in doing detailed review, let alone fixing typos, if we don't have any idea what the patch is attempting to accomplish, or we don't want that. Once we've got some idea that the patch does something that we might want, and we know what that thing is, then at the second level of the pyramid here, I put architecture and design. So basically, if we agree on the goal, then do we agree on the way that the patch goes about that goal, at least in broad strokes? So here I list things like, for example, safety. Does the patch violate some invariants in the code which are going to result in it doing bad things like crashing the system or eating your data? Is the design conducive to good performance? That's especially relevant if it's a performance patch, obviously, but even if it's not a performance patch, we need to ask whether a design has been chosen which is likely to regress the performance of other things. And maintainability. Are we going to be able to maintain this code? Is it going to need to be constantly updated? Are there going to be updates that will need to be made to this code by future patches that someone will be likely to miss when they are reviewing those patches? And then user interface. If we're doing something that affects SQL, whether it is new or modified SQL syntax, or even just a function that could be called, there's a user interface. And we can talk about whether that user interface is good or bad, whether we like it or we think there's room for some improvement. PSQL features have a user interface as well. And sometimes even things that are strictly internal and are not directly exposed to the user have maybe not a UI, but an API. So then there's still something to talk about whether that API is good. Is it going to be something that is usable? So once we're sort of sorted on those points and we think that in broad strokes the patch is going in the right direction, then it makes sense to start thinking about detailed review. I suspect that some people would quibble with the way that I've divided things between the yellow and orange layers here in particular. But I don't know what everybody else does, so I'm going to talk about how I approach it and understand that there are likely some differences. I tend to look pretty early on at patch set structure. Has the patch set been broken up into a series of patches in a way that's logical? If somebody just takes their whole patch and breaks it up by directory and says, here's a patch set where I've got the changes for each directory in a separate patch file, well, that's not useful at all. It has to be broken up in a logical way where each patch is a separate change that could potentially be applied separately and in the order in which those changes were submitted. It doesn't do any good to have the prerequisite patch the last thing in the series. You know, you got to do the infrastructure first and then proceed to the things that depend on it, which kind of seems obvious, but people don't always do it. The other thing I look at quite a bit here is, you know, has somebody included commit messages? Have they included code comments? And it's actually quite common that people don't. I think that a very common reason why this happens is that we are a very international project and not everybody feels super confident with their grasp of English or their ability to write comments that are going to be up to standard. I will say, I would much rather have some comments in the best English that you can manage than no comments at all, because it makes it much easier to review the patch, and even if I might feel the need to rewrite the comments, rewriting the comments that you provided is a lot less work than writing them from scratch, where I'm first going to have to figure out what the code does entirely by inspection. I also tend to look at code structure. You know, are we using subroutines in ways that make sense, for example? Are we putting the code to do things in the right directories? Or are we maybe doing something that belongs in one part of the code base and a completely unrelated part of the code base? And I often do some manual verification at this stage as well. And then from there, I go into detailed code review, line by line code review of the entire patch. And I'll also check at this point whether things like, is there documentation? Are there tests? Are the tests passing? Is CI passing? I don't really care that much whether you've got documentation and tests in the initial review of the patch, unless, of course, the lack of documentation leads to the patch not being understandable. Because if you don't give me some information about what you're trying to accomplish, maybe somebody else will understand it. I've noticed we have a few people who are extremely good at grasping the meaning of a patch set that isn't documented, but I am not one of those people, and I really like to be told what you thought you were trying to accomplish. And then there's final polishing, coding style, PG indent, typos, maybe some rewriting of comments for grammatical reasons, things like that. And once we've got all of that sorted out, then the patch can be committed. I do notice too many people start at the top and they never get to the lower levels of the pyramid, and that's really a shame, because actually, even if you're not a coder at all, you might be able to comment on the UI, for example. And if you're a user, you know, you could comment on desirability. You could read and understandability. You could read the goals of the patch and see whether it seems like a good idea and whether it's something that you like. Now, moving from bottom to top of this pyramid is an aspirational goal. Like, I know that I should try to go from bottom to top, but I can't always actually do it. When I read through a complex patch for the first time, I may comment on a lot of small stuff and totally miss the design problems with the patch, which I may find on my second or third read through, because I'm gradually understanding the patch better as I go through it, and along the way I'm making notes about things that I see that are going to need to be fixed. And occasionally it happens to me that I start to write a long email about smaller things that could be fixed, and then 3/4 of the way through the patch I realize, oops, there's some killer problem here that means all of that text that I just spent time writing is completely useless, and I throw it away. But sometimes that doesn't even happen until I'm reading the patch for a second or a third time. And as I mentioned, even though comments and commit messages can be polished a bit later in the process, I often ask for improvements just so that I can understand the patch in order to be able to properly review it. I want to talk about reviewing for consistency, which I think is a real bedrock principle of reviewing PostgreSQL patches. I think it's easy to not understand how much effort people put into doing this and how important it is, because it can feel like nitpicking, like, why are you insisting on these small points? But I think there are actually some really good reasons to review for consistency again, and review for consistency a few more times after that. The first one is that it's a good way to refute political objections. If somebody looks in the patch and sees something that they don't like and asks you why it's like that, and you come back and say, well, because the other 10 cases that we already have in the source tree are like that, that's a pretty good reason. I mean, they may still not like it, but it isn't a problem you've created, and it's not your patch's fault. Of course, it also avoids bugs, right? If you take some existing code and adapt it rather than doing something totally from scratch, it's more likely that you're not going to miss anything crucial to having it actually work. Also, and I think this is actually really important, it makes the code more readable and maintainable. If you see some PostgreSQL code and it looks a lot like other pieces of PostgreSQL code that you've seen before, you will have an easier time understanding what is actually happening there. And finally, of course, inconsistencies could, in an extreme case, creep out into the user experience. And then, that would be bad for users, right? So this is kind of a silly example because it's so extreme and we're all so used to the way that it works. But just imagine if every time somebody added a new type of object at the DDL level, they decided which verb they like best for getting rid of objects at that type. Then you might end up with the person who did tables saying, well, we're going to drop tables when we don't want them anymore. But the person who added functions might say, no, we're going to remove functions when we don't want them anymore. Well, this would be terrible because you'd end up with a hodgepodge, right? So we want consistency stretching out into the user experience as well. The idea of reviewing for consistency applies to both high-level review, is the architecture consistent with what we've done elsewhere, and also to low-level review. Is the exact way that this code is written similar to what we've done in other cases? One of the things that makes it hard to become a skilled PostgreSQL hacker is that our code base is full of what I call coding micro-practices. Little things, numerous little things, that we almost always do in the same way and which you're encouraged not to deviate from, again, unless there's a compelling reason. So I wrote this sample code to kind of demonstrate this point. This code is pg-indent clean. If you run pg-indent on it, it will not be re-indented. It compiles without warnings. And if you're really lucky, it might even work. But if you're used to reading PostgreSQL code, you can probably see that there are quite a number of problems with this code, which I'm about to enumerate. Or at least I'll enumerate the ones I know about. But I'll give you a sec to look at it and see how many you can see, and then I'll tell you the ones that I deliberately included. So we don't put extern in the function definition, only in the function declaration. There's nothing wrong with it, but it's a convention that we universally follow. We try to declare variables in the innermost scope, so those two variables, h and dbstruct, should be in the inner scope rather than the outer one. They should also be named differently. Pretty much every variable of type heap tuple in the entire code base uses a name like tuple or toop or htoop or dbtoop, not just h. And similarly, we would never call a variable of type form PG database dbstruct, even though you obtain that pointer by calling a macro called getStruct. We call that variable something with form in it, like form or dbform. We would not use palex0 here because that will zero the entire array, and we're about to overwrite every byte of the array. So we don't need to pre-zero the memory, it's just wasted overhead. A committer might or might not call you on writing ++i here, but if you check the source base, you'll find that we write I++ about 9 times as often as we write ++i. So there's a 10-to-1, there's a 90-10 preference for writing that increment operation the other way around. We never call search syscache directly, even though it works fine to do so. We always call a macro such as search syscache1 should be used in this case, which would supply 3 trailing zeros so that we wouldn't need to include those here. And the first really serious bug in this function is that there's a missing object ID getDatum call around OIDs bracket I, which will make this code work on some endianness and fail on the other endianness, which is why you could even potentially test this code and not discover that you've made a mistake. But don't worry, the build farm will tell the committer that you made a mistake. It definitely will. We do not write an h == null test. We typically use the heap tuple is valid macro for that. That's not the standard error message that we use to complain about a missing catalog tuple. And the release syscache call there is the second serious bug that I know about in this function because it invalidates the pointer that we just stored into the return array on the previous line. And that, again, may appear to work because, by default, we don't always clobber caches instantly when the memory is freed. But once again, don't worry. The build farm will tell you right away if you make this mistake. Oh, yes. Oh, yes. Very, very quickly. And I think this release syscache error here, this is one that like probably every committer has made multiple times, right? Like it's just so easy to do. Most of the things in this, I would imagine, to the committers in the room who have reviewed a lot of code over the years, it kind of jumps out at you that a bunch of this stuff is not the way we normally do it. That one's, I think, quite easy to miss. So my point here is really that any reviewer with some knowledge of C can find every one of these problems. You just grep for similar examples, and then you do a very careful comparison between what those examples look like and what this looks like, and you can find all of this stuff. But you might not, right? Because you might not be used to having that level of scrutiny of the details of what you did. But there is no way that we are going to end up with 500 messages that say cache lookup failed for database %u and one message that has this alternative error text. That is not going to be how this goes. So this is the kind of stuff that committers spend actually, I think, quite a lot of time hunting for in patches that they review, even after they're confident that the overall structure is right. I managed to pack, I don't know, more than a dozen errors here into a pretty short function in which I didn't even include any comments just because I wanted to make it fit on the slide a little bit better. But just imagine what happens when somebody submits a 4,000 line patch. You can have stuff like this in any of those 4,000 lines. Let's take that one offline. We do have code like this. But anyway, let's take that one offline. Yeah, so the search syscache, the cache lookup key is a datum, not an OID. And a datum, when you put an OID into a datum, you're either just sticking the OID in the datum and the other 4 bytes are zeros, which is what this will do, or on some NDNSs, you're byte swapping it. We can catch up after. But trust me, that will not work. It might work on your machine. It won't work on all of them. All right, so let's talk about pessimism. Some of you might be surprised, or maybe the word I'm looking for is dismayed, to hear Robert Haas calling for more pessimism. Because if you know me, or you've read enough of my emails, you might be under the impression that I'm one of the more pessimistic human beings around, and you are right. But when I look at my own reviewing failures, like things where I committed the patch and I missed something important, typically they don't come from the fact that I lacked sufficient knowledge or understanding to find the bug. That's happened, but it doesn't happen that often. Because most of the time, when that is a risk, I realize I'm not qualified to review this patch, and I stop. And I wait for somebody else who is qualified and will be able to fix whatever breaks to show up and review the patch, and I stay out of it. Or I take my time to learn the area well enough that I feel like I can be responsible for it. But a mistake that I make all the time is thinking that a certain kind of error probably won't be present, and therefore I don't need to check for it exhaustively. You can, for example, assume that if somebody says they've implemented a linked list, that they probably know how to implement a singly linked list. After all, that's probably something that you learn in your first programming course. But do you know how many broken implementations of that kind of thing people submit? The answer is lots. People mess that kind of stuff up all the time. Linked lists, hash tables, binary searches, all sorts of fundamental algorithms. People do them wrong. So, authors miss all kinds of things. They miss design flaws. They don't check all the different parts of the code. They miss regressions. Lots of things happen. Extreme pessimism, in my experience, is still often not enough pessimism. So how can you actually go about being pessimistic? In general, I don't know that I can really give perfect guidance on that, but I will share a couple of tips that I found useful. One is, use git grep a lot. If the patch is changing something related to identifier XYZ, git grep XYZ will find every place where that identifier is mentioned in the source code, and maybe one of them has not been adjusted for whatever the change is that the person is making. And you want to notice that. One of my first patches, I think actually the first patch of mine that got committed, was to add a grantable truncate privilege. And so I found, after some searching around, that there was this useful identifier, ACL-delete, that seemed to me to allow me to find practically all of the places in the source code that I needed to modify to make my feature work. And so I added a new identifier, ACL-truncate. I searched for all the existing instances of ACL-delete, and I made all of those places do whatever the right thing seemed to be with my new symbol. But of course, you can also apply this during review. You see that somebody's adding something, you find something similar that already exists, you grep for that, and maybe you find that some cases were not adjusted. I also find it quite useful to think about pairings, what operations logically go together. Well, one clear case is that if a resource is allocated someplace, that resource probably needs to be deallocated. If we allocate memory, maybe it needs to be freed. If we're creating a file, maybe it needs to be removed. If we're setting a global variable, maybe it needs to be cleared. Sometimes it doesn't. Sometimes it's going to happen automatically as a result of some built-in PostgreSQL mechanism like memory contexts. But it's a good question to be asking whether the code that you see means that some other code needs to exist somewhere, and if so, does that other code actually exist somewhere? A variant on this same theme is to sort of consider the system-wide consequences as well as you're able. This is a point that really benefits from having more knowledge of the system. So it is, I think, a key role of committers to notice when some part of the code that might be quite far removed needs to be modified as a logical consequence of whatever is being changed. So for example, if you add a new DDL command, create strawberry, well, of course, you're probably going to realize that you need alter strawberry and drop strawberry, alter strawberry, rename to, alter strawberry, owner to. But are you going to remember that pgdump needs to be updated? Because now strawberries are a thing that exists in the system catalogs, and that means they need to be dumped and restored, just like all of the other objects that you can define. Hopefully, yes. Maybe PSQL needs some kind of new command. I doubt we'd pick one that long, but you get the idea. Another really good use of your pessimism is to think about the possibility of functional regressions. If this patch did have a bug someplace, where might it be? And then poke at that place and see if it actually does. Performance regressions. If there were something that this patch slowed down, what might it be, and under what circumstances might that thing happen? Then you can do testing and benchmarking to either confirm or rule out the possibility that there is a problem. You do, though, and I emphasize this point particularly, need to have pessimism about your pessimism. Because it is very easy to say, oh, if there were a bug, it would probably be over here. Then you go and test, you don't find a bug, you say everything's great, but the problem was actually in your test. Your test didn't really exercise the portion of the code that you thought you were exercising, and so the bug was there, but you just didn't find it because you messed up. I cannot recommend enough adding temporary debugging code. That's my preferred technique for making sure that I'm actually hitting the new code, or using a debugger or a profiler. You got to make sure your test or your benchmark is doing what you think it's doing. Otherwise, the results are not valid. And I think this is an area where people are very, very often too optimistic. They either fail to identify the cases where the patch might be really bad, or they fail to actually hit them. Finally, I'll just say a couple of very brief words about the spirit of maintainership. This project is something that we're all doing together. We're all in it together. Many of our livelihoods depend on the success of this project. And that means that we need to do what's good for all of us, not what's good for somebody who has a really serious problem that they need to solve that day. There are very often arguments on the mailing list that a particular patch is worth a 3% performance regression, or worth a user interface wart, or worth an annual code maintenance task. And sometimes those people are 100% correct, because some patches are worth those things. But if we accepted 10 patches like that every release, then every release we'd have a 30% performance regression, 10 user interface warts, and 10 annual code maintenance tasks, and we would be in a huge amount of trouble very, very quickly, right? So we have to be super judicious about incurring those costs, and sometimes the answer is just time. We wait and see. We gather more information. We try to find out, is this change actually important enough to justify, to enough people to justify the hit we're incurring. I think it's really important to be respectful of the fact that the patch author always has good reasons to believe that their patch is beneficial to the project. We shouldn't just tell people, go away, your idea sucks. They certainly have good reasons to believe that it doesn't. But at the same time, we can be cautious about whether the downsides associated with that patch really make sense, especially if the downsides are going to be borne by everyone and the upside is something that's only going to benefit the people who use the feature. That brings me to the end of my slides. Thank you all for coming. I think we have a couple of minutes that we can take questions here. Looks like about 5. And thanks so much.
So as someone who is not a contributor to Postgres and doesn't know the development system and process very well, I've heard a couple of times that there are issues, especially in the code snippet we saw, that will be caught by the build farm eventually. In your opinion, is it possible or reasonable to leverage those test cases and rigorous tools to find bugs before someone like you or someone with commit privileges has spent a significant amount of time reviewing it in more detail?
That's a phenomenal question. We have made some significant progress in that with the CI setup that Andres and several other people work really hard on. We do not have parity between CI and the build farm. So CI catches a bunch of stuff, and then the build farm sometimes catches more things. I think that one of our priorities as we look to improve this area should be to rethink how we're doing certain kinds of things so that CI can catch a greater percentage of the issues. I think it would lower everybody's blood pressure by, I'm going to say, 5 to 10 points. Other questions? I think there's one. Oh, okay, Noah.
Yeah, I was just thinking that in this context, paranoia sort of seems like a ratchet that only increases. So how do you decide when to relax to any extent on any issue?
Yeah, that's a great question. One of the things I think we can look at is what is our actual error rate after the paranoia, right? If nothing ever goes wrong and we just spend a bunch of time being paranoid, then apparently we're too paranoid. The evidence doesn't suggest that because, for example, I went through the commits from February and I found about 20% of them were post-commit fix-ups. So there are a significant number of issues, and I think another 15% or so were bug fixes from commits longer ago. So we are still having a pretty good amount of stuff slip through. I think, we need to think more in the direction of how can we catch mistakes earlier and with less effort and put less manual load on the committer, as the gentleman over here was saying, rather than in the direction of being less paranoid. Because until we have better tools, unless we see the error rate start to decline from where it is, we're going to have to keep up with the paranoia. Are we at time? 1, 2 more questions.
So how does the paranoia degrade or increase over the course of the release cycle, beginning to end, and where is sort of the threshold where it gets extremely high?
Well, what should happen is the paranoia should be highest at the end. What actually happens is it declines at the end because people are desperate to get their patches in, and then what sometimes happens is a flurry of reverts as people realize what they should have known, which is that that wasn't up to standard. I think the only thing that keeps that from becoming a total mess is the fact that we do have a feature freeze, and that feature freeze removes a certain amount of human judgment after that point, because then you're not committing things unless everybody agrees that it's a bug fix for something that was already committed. So that keeps the craziness from getting too far out of control. But the fact that we need that so badly definitely shows that people's spirit of maintainership is not always quite at the level that perhaps it should be. One more question, Darshan, I believe.
Hey Robert, thanks for sharing all this. This is quite a bit of learning from you, maybe like 15 years of work you are doing here. One question related to this new generation where a lot of people are using Gen AI. Do you think are they at a stage where it can help you or committers to review the code before it even comes to the CI stage?
I think the AI technology is developing quite rapidly, and so I definitely would not rule out the possibility that it will get there. But right now, I would say definitely not, right? I mean, we all know that AIs hallucinate quite a lot. And you can see from examples like this how even a tiny amount of hallucination gives you an uncommittable patch. So that doesn't feel like we've got the necessary level of reliability there yet. All right, that's all the time we have. Thanks, everyone.